66 stories high, 10,000 tons, and precision measured in millimeters. These aren't the stats for China's newest skyscraper. They describe the world's most impressive ship elevator. The Gupingtan shiplift carries cargo vessels weighing as much as 50 blue whales up a vertical cliff face, transforming a region once crippled by geographic isolation. While the Three Gorges Dam shiplift was already impressive, handling 3,000-ton ships, the Gupingtan system takes the technology to new extremes. Ships that once took 4 dangerous days to navigate through mountainous terrain now make the journey in just 2.5 hours. This engineering feat has slashed shipping costs by 67% and increased industrial output by 42% in a previously forgotten province. Here's how they built it. Imagine waiting 4 hours while your cargo ship inches through a 5-stage lock system. That was standard procedure at the Three Gorges Dam before the shiplift era. The dam's traditional lock could handle 180 million tons of cargo annually, but this engineering marvel came with a frustrating drawback. Each vessel required nearly half a workday just to transit the barrier. For businesses shipping goods along the Yangtze River, this created unpredictable delays and scheduling nightmares. The Three Gorges shiplift changed the game when it launched in 2016. Its 122-meter chamber could hoist 3,000-ton ships in just 40 minutes, bypassing the slow lock system. Engineers filled the chamber with enough water to fill 4 Olympic swimming pools. But when China looked to develop Guizhou province's mountainous regions, this technology hit its limits. The karst landscape demanded vertical lifts that dwarfed anything attempted before. Guizhou's terrain presents unique challenges. The Wujiang River drops 199 meters, nearly 2/3 the height of the Eiffel Tower, through a series of steep gorges. Traditional locks would require dozens of stages here, making shipping commercially unviable. The Three Gorges shiplift design couldn't scale to these elevations either. Its water balance system worked well for moderate climbs, but couldn't handle Guizhou's extreme vertical changes efficiently or safely. This transportation bottleneck had real economic consequences. Shipping through Guizhou cost 3 times the national average, discouraging industrial development in the mineral-rich region. Factories avoided the area despite its resources. The existing river infrastructure couldn't support modern cargo volumes or vessel sizes. Something entirely new needed to be invented to connect Guizhou with China's main shipping routes. The solution emerged at Gupingtan. Engineers designed a 3-stage elevator system that could lift ships vertically like skyscrapers carry people. Instead of a single massive chamber, they created smaller connected lifts that could handle 10,000-ton ships, triple the capacity of the Three Gorges system. The complete transit now takes 2.5 hours compared to the 4 days previously needed to navigate the winding river. This system makes previously impossible shipping routes viable. Cargo vessels no longer need to follow the river's natural path through the mountains. Instead of creeping through dozens of locks and dangerous rapids, ships can take the express route straight up the cliff face. The time savings alone have revolutionized regional transport economics. But the true innovation lies in how the system achieves this vertical movement, while maintaining precise control over massive weights. Building this technology required overcoming fundamental physics challenges. Unlike the Three Gorges water balance system, Gupingtan's design needed to reliably move variable weights, sometimes empty chambers, sometimes fully loaded ships, with equal precision. The engineers developed a hybrid system that combines multiple lift mechanisms, each optimized for different phases of the operation. This modular approach allows for both energy efficiency and the flexibility needed to handle varying loads. At its core, the Gupingtan system rethinks what ship transport can be. Rather than copying dam-based designs, it applies principles from industrial elevators to maritime logistics. The three-stage configuration means ships experience relatively gentle transitions between elevation changes, avoiding the turbulence and water management issues of traditional locks. Every component had to be custom engineered to handle the unprecedented combination of vertical height and cargo capacity. The Gupingtan shiplift operates with the precision of a Swiss watch at a scale that's hard to comprehend. Each of its 256 steel cables can handle 300 tons of force, enough to tow a Boeing 747. Together, they support a water-filled chamber weighing 11,000 tons while maintaining alignment within 10 millimeters, about the thickness of a pencil. This margin of error leaves no room for guesswork when moving ships as tall as apartment buildings up a 199-meter cliff face. Traditional counterweight systems proved inadequate for Guizhou's mountainous terrain. Earthquakes and shifting rock formations required a different solution. Engineers developed the gear rack plus nut column system, which works like a massive mechanical clock. Interlocking teeth made from a special alloy climb vertically along a rack, providing controlled movement while absorbing micro vibrations. This system maintains stability even in high winds or seismic activity, where conventional designs would fail. 4 concrete towers anchor the entire structure, extending 70 meters into bedrock, deeper than the visible height of the lift itself. These towers serve dual purposes, guiding the chamber's vertical path and dissipating earthquake forces. Each contains redundant systems, including backup cables, hydraulic buffers, and emergency brakes. The foundations use seismic isolation technology, allowing the structure to sway slightly during tremors without compromising integrity. Safety redundancies are baked into every component. If power fails, multiple braking systems engage simultaneously. Hydraulic arresters can stop the full 11,000-ton load within 2 meters, preventing catastrophic collisions. The dampers alone contain enough fluid to fill an Olympic swimming pool, capable of absorbing forces equivalent to a meteorite impact. 5 independent computers continuously monitor operations, cross-checking data 1,000 times per second. Any discrepancy triggers immediate shutdown protocols. The gear mechanisms deserve particular attention. Unlike traditional ship lifts that rely on water balancing, Gupingtan's design uses mechanical teeth that mesh with near-zero clearance. Each tooth undergoes ultrasonic testing for microscopic cracks before installation. The alloy composition allows just enough flexibility to prevent brittleness under load while maintaining rigidity for precise movement. This hybrid approach was custom developed for this project, as no existing material met the dual requirements of strength and vibration absorption. Water management presented another challenge. The chamber holds 15,000 cubic meters, equivalent to 6 Olympic pools, but must remain perfectly level during ascent. Engineers installed 36 laser-guided sensors that adjust buoyancy in real time. If waves from wind or ship motion exceed 50 millimeters, auxiliary pumps activate to stabilize the water surface. This prevents sloshing that could unbalance the entire load. The control room operates with aviation-level redundancy. Every critical system has at least 3 backups, from power supplies to communication lines. Operators train for 2 years on simulators before touching live controls, rehearsing scenarios from earthquakes to cable snap failures. During actual lifts, drones provide live overhead views, while underwater cameras monitor the chamber's submerged components. What emerges is a system where mechanical and digital safeguards work in tandem. The physical structures handle brute forces, while the electronics manage precision. Together, they achieve something unprecedented, moving ships vertically through a mountain range with the reliability of a metro train. This integration of scale and accuracy explains why Gupingtan's design is now being adapted for other extreme elevation projects worldwide. The true innovation lies in how these systems interact. seismic sensors communicate directly with the gear mechanisms, briefly pausing operations during tremors. Wind monitors adjust ascent speeds to minimize sway. Even the water level controls interface with the braking system, ensuring smooth stops regardless of cargo weight. This interconnectedness allows the lift to handle variables that would cripple lesser designs, whether it's a half-empty chamber or a fully loaded coal barge. Future upgrades are already in development, including AI-driven predictive maintenance. Vibration patterns from the gear teeth can indicate wear before visible damage occurs. Similarly, thermal cameras detect abnormal friction in cables, allowing preemptive replacements. These advancements aim to push the operational precision even further, potentially reducing the current 10mm tolerance by half within the next decade. For now, the system represents the cutting edge of heavy vertical transport. Every journey relies on thousands of synchronized components, from the steel teeth gripping the rack to the algorithms balancing water displacement. It's a reminder that true engineering breakthroughs often come from perfecting interactions between systems, not just the systems themselves. The shiplift doesn't just move weight. It orchestrates physics on an industrial scale. Guizhou province was once an economic afterthought, trapped by its own geography. Before 2021, shipping a container from this mountainous region to Shanghai could take 2 weeks and cost 3 times more than comparable routes across China. The Wujiang River, winding through jagged limestone peaks, remained effectively useless for modern shipping. Factories avoided setting up operations here, despite abundant mineral resources, as transporting raw materials in or finished goods out made no financial sense. This isolation created a vicious cycle. Without industry, there was no investment in infrastructure, and without infrastructure, industry couldn't develop. The Gupingtan shiplift broke this cycle by connecting the Wujiang directly to the Yangtze River system. It created a 5 million ton freight corridor overnight. Suddenly, companies could move bulk cargo efficiently for the first time. One aluminum processing plant saw its transport costs drop from $38 per ton to just $12 per ton after the lift became operational. These savings made previously marginal operations suddenly profitable, transforming inventory decisions and market strategies across multiple industries. Foreign investment responded dramatically. Within 3 years of the shiplift's completion, Guizhou recorded an 83% increase in overseas capital. This wasn't just about shipping companies. Manufacturers, logistics firms, and support services all rushed into the newly accessible region. The project created 112,000 direct and indirect jobs, many in sectors that previously couldn't exist in the province. Towns along the Wujiang saw their populations grow as workers relocated for these opportunities. Industrial output tells the most striking story. After decades of lagging behind national growth rates, Guizhou's annual production surged 42% post-lift, the fastest expansion rate of any Chinese province during that period. This wasn't just about moving existing products more cheaply. Entirely new industries became viable. Advanced manufacturers could finally source materials and ship components cost-effectively. Agricultural exporters gained access to coastal ports without expensive trucking. The economic multiplier effect rippled through the entire region. The transformation extended beyond pure economics. With reliable transport came infrastructure investment in roads, rail connections, and utilities. Workers drawn by new jobs needed housing, schools, and services, creating secondary construction booms. Local governments gained the tax base to improve public services. The shiplift didn't just change shipping routes, it redesigned the entire economic geography of southwest China. Energy-intensive industries benefited particularly. Guizhou's bauxite deposits were suddenly economical to process locally rather than shipping raw ore elsewhere. aluminum smelters could operate profitably when their output could reach markets efficiently. Similar dynamics applied to phosphorus mining and chemical production. These sectors require massive, heavy shipments that were prohibitively expensive before vertical shipping became possible. The timing proved crucial too. Completed just before global supply chain disruptions, Gupingtan gave manufacturers an alternative to congested coastal ports. Companies could now route cargo through China's interior waterways more reliably. This strategic advantage attracted firms looking to diversify their logistics options, further boosting Guizhou's appeal. Statistical comparisons show the dramatic shift. Where Guizhou once ranked near the bottom in provincial economic indicators, it now leads in growth metrics. The Wujiang corridor handles more freight each year than the region's entire road network moved before the project. Shipping times to Shanghai dropped from weeks to days, with predictable schedules that businesses can bank on. This reliability matters as much as cost savings for many operations. The economic changes continue evolving. With reliable transport secured, companies are investing in value-added processing rather than just raw material extraction. More finished goods now ship out instead of bulk commodities, capturing more profit within the province. The next phase of development focuses on technology and advanced manufacturing, sectors that require precisely the kind of efficient logistics infrastructure the shiplift provides. With 24 similar projects planned under the Belt and Road Initiative, this technology's impact extends beyond China. The design principles developed here are already influencing infrastructure projects in Southeast Asia and Africa. These adaptations consider local conditions while applying lessons from Gupingtan's precision engineering and economic transformation.